Okay, here we are again, part 2, set K. Let me see what the instructions in your packet say. Oh, they just say to simplify. Okay, so the square root of x squared comes out to be x. I think I probably have done a couple of these where I didn't even talk about it. The square and the square root kind of undo each other. Or you can think of it as square root of x times x. And we know that that's square root of, rewrite it like this even. Woo, that's fun. And that's going to give you x. All right, square root of 8x squared, it doesn't matter how you write it, is going to come out to just be 8x. The square root of AB, quantity squared, is just going to be AB. This square undoes this radical. Set L. Here's what I'm going to do. I'm going to take 3 times 4. I'm going to take I guess they're called a coefficient. 4 times 3 is 12. Square root of 5 times the square root of 2. I'm going to combine that together. I get 12 square root 10. I can't reduce 10 or do anything with it, so I'm going to leave it. If I had to reduce that, I should. I need to. 5 times 2 is 10. Underneath the radical, I have a 21q. Okay, 21 doesn't break down, neither does q. No sense in splitting, just leave it the way it is. And then finally, t and v, so I have tv square root hr. Set m. All right, you got to be careful with this one. I'm going to write this one out twice to kind of show my work. 3 square root 2 times 3 square root 2. And kind of do the process we did before, is 9 times, oh yeah, that's just 2. 18. Okay? Here's your shortcut. You gotta be very careful with this. You can square 3, which gives you 9. You can square root of 2, which gives you 2, and you end up with 18. Be very careful when you do this. 4 squared is 16, and square root of 5 times square root of 5 is 5. 16 times 5 is 80. If you're stuck, just write it out. Write out c square root 7 times c square root 7. C times c is c squared. Square root of 7 times square root of 7 is 7. We don't like to write things like this. We want our coefficient out front, 7c squared. Set n. Okay. On this one, we can just write square root of 20 over square root of 5 is the same as square root of 20 over 5. Oh, but wait. Square root of 20 over 5 is square root of 4. The square root of 4 is 2. Here, square root of 4 over 3. And there's actually nothing more you can do this. This is another skill that we're going to use later. We would actually do a little more simplifying on this, but this is one of these little practice drills. I want you to realize that when they're written separately, they can also be written underneath one radical or under separate, depending on what you need to do with the problem. Okay, another skill here, we're going to write it underneath one radical, 8x over 7y. Check, does anything reduce? In this case, and in this case nothing does, but in this first case it would. Okay. Set O. Now you have them written as 2 separate. Now I'm going to write them under one radical. And then, oh, that breaks down to be 25, and the square root of 25 is 5. Most of the time, you will not even have to write this step out, I would guess, if you're catching on. X cubed over x is actually x squared. There's a 1 here. 3 minus 1 is 2. When we are subtracting with like bases, we subtract, oh my gosh. When we are dividing with like bases, we subtract our exponents. Square root of x squared, plain old x. Now I'm going to write this under one radical. (32 over 2 is 16. X to the 5th over x to the 3rd is x squared. The square root of 16 is 4. The square root of x squared is x. 4x is my final answer. P. Now we're set P. We're splitting the radicals. So we have square root of 7 over square root of 12. Once again, this is actually in our, when we're done with this packet, this will be incorrect. But for now, we are just practicing a skill. I want you to realize that if you have 7 over 12 under the radical, it can be written separately, and then you can work through the rest of the problem. At this point, we're just going to leave this set P like this. So you can write set x over set y. Set x over set y. Or, oh my gosh, I said set. I meant square root x over square root y. Same here. Square root math over square root geometry. Okay, moving on. Set Q. We're going to split and then conquer. So the skill that we're working on here is taking the square root of 16 over square root of 25. Sometimes we're going to need to write a radical separately. So square root of 16 is 4, square root of 25 is 5. Done. Square root of 4x squared over square root of 100. The square root of 4 is 2, the square root of x squared is x, and the square root of 100 is 10. We are not done. Don't let your basic mathematical knowledge leave you. Can you leave an answer 2x over 10 in Mrs. Talley's class? No! You must reduce x over 5. 2 over 10 reduces down to 1/5. And I don't have to write the 1. You can if you want, but I'll just leave x over 5. M squared over t squared. Square root of m squared over the square root of t squared. The square root of m squared becomes m. The square root of t squared is just t. That's all there is to that. Okay, set R. It is illegal to have a radical in the denominator. So now we're going to take the skills that we've learned and apply them to this, except we're going to have this new rule in here. You can never leave a radical, a square root, in your denominator. You can use it in a problem while you're working through it, but your final answer should never have a radical in it. You'll miss it. You'll automatically miss it on a test, a quiz, anything that I'm grading. All right? So here's what we do. We're going to take both the top and the bottom of here by square root 3. And the reason I'm doing that is because, this is so cool. Square root of 3 times square root of 3 is 3. I no longer have a radical in the denominator. I don't want to forget my 7 here. And 5 times square root of 2 times square root of 3 is 5. And now I use that skill. I can write that square root 2 times square root 3 underneath the radical of square root 6. Not square root 5, but square root 6. All right. And then I'm going to simplify out 5 square root 6 over 21. Please note, what is the value of square root 3 over square root 3? If you did that on your calculator, 1. So this right here, this number, is equivalent to this number. If you were to put this into your calculator, and if you were actually able to put it in correctly, and put this one into your calculator correctly, the decimal approximations would come out to be the same. Okay, moving on. Let's look at some variables here. I've got to take both the top and the bottom times its denominator. So square root h and a square root h on the top and the bottom. So I have f square root gi over, don't forget the h. This little h is saying, don't you forget about me. No, 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 don't you forget about me. All right, here's what square root of I times square root of I is I. Oh, look at that, hi. Ooh, I'm just going to rewrite that because that is too much fun. Hi. Last one here. Got to take both the top and the bottom times square root 2. Square root 2. This is called rationalizing your denominator. You're turning rational number out of your denominator. See, we got 2 square root 16. And we have this 3 here that we're not forgetting about. Square root 2 times square root 2 is square root 4. Or a lot of us would just write 2, which would have been faster. So now in the numerator, I have 2 times 4. In the denominator, I have 3 times 2. 8 over 6. And no way will you leave that as your final answer because it can be reduced to 4/3. Set S. Once again, avoid your tickets. We're going to multiply the top and the bottom times square root 5. Remember the value is 1, so I can multiply anything by 1. So this radical problem would stay the same value. Square root of 15 over, square root of 5 times square root of 5 is 5. I could break down the top if I needed to, but square root of 15, the numerator there, will be square root of 5, square root of 3. It's not getting me anywhere to go and do that. So I will leave square root of 15 over 5. Take the top and the bottom times the radical that's in the denominator. So I have square root of 12, and I don't want to write that x at the end. I'm going to put times and then x. I'll rewrite it. Square root of 12 times square root of 12 is 12. Now I have students who wonder, can you cancel those out? No. One is square root of 12, the other is a 12, and they do not cancel. It's not like 5 over 5. Let me rewrite this. Square root, I almost caught myself not doing something correctly. Square root of 12, isn't that got a perfect square number in that? It does. So it's actually x times square root of 4 times square root of 3 over 12. This becomes 2. So I have 2x square root 3 over 12. And yet, it's still not done because by golly, that little 2 and that 12, if I just gave you a fraction like on a math minute that was 2 over 12, you'd be like, oh, that's not right. You got to simplify. So it's going to be 1/6, right? So I'm going to have the x square root 3. I'm not going to bother writing the 1. Oh, I said 6, and I almost wrote a 3. Okay, so I should have x square root 3 over 6. That is my final answer. Try it again down here. Square root of 10, square root 10. Both the top and the bottom multiplied by that radical in the denominator. So now I have 5 square root 60 over 2 times 10, because square root of 10 times square root of 10 is 10. Square root of 60 has a perfect square number that goes into that. 4 times 15. You got to know your multiplication. You got to know some of these basics here. I got to erase this a little bit to give myself some room. All right. Square root of 4 becomes 2. So now I have 5 times 2, which is 10, square root 15 over 20. And once again, 10 over 20 can be reduced to 1/2. So I don't want you to write your answers like that. Don't turn in your paper like that. That could be a work step, but now your answer. Square root of 15 over 2. Done. That's it. And I think we are done as well.